So chemistry for beginners. Yeah. So if you're a beginner, you need to listen to this. All right. So chemistry for beginners. Who is here? Drop a comment if you're online. Okay. Drop your comment. Drop your comment. John, you're here. Are you here? Drop a comment. Good. So we stopped at compound. So I already explained what an atom is. I already explained what molecule is. I already explained what element is. Understand? Then now we are at compound. So compound now, I said when two or more elements combine. I'm from Nigeria. You can subscribe if you are just joining. Chemically together. Then we say that is what? A compound. That is what? A compound. That's a compound. Now, don't also forget that we can have NaCl. This is a compound, right? Because this is an element. This is also an element. So if these two combine together, chemically together, then we call it a what? A compound. We call it a compound. You understand? Chemically together, then we call it exactly. It is a common salt. Yes. So this is what we call your common salt. This is also what is referred to as normal salt. This is what we eat at home. You understand? NaCl is a common salt, and it's also normal. You understand? It's also a normal salt and it's a common salt. So take note of that. And it's a compound, right? Another very fantastic example is Na2SO4, right? Because this is sodium, this is sulfur, this is oxygen. Now, because they are elements and they are combined chemically together, this is also a compound. And this is also a salt. It is a normal salt. It is a normal salt. You understand? So this is a compound. So we can have a lot of examples like HNO3 is a compound. H2SO4 is a compound, right? We can have We can have H3PO4 is a compound, but these are also acid. This is a strong acid. This is another strong acid. This is another strong acid. Okay, they are all compounds. Why? These are elements, but they are combined chemically together. Understand? These are elements and they are combined chemically together. Understand? So please take note of that. Very, very important. I can say that MgSO4 is also a compound, magnesium sulfate. Understand? I can say CuSO4 is also a compound. They are combined chemically together. Yes, you can subscribe to my channel. Currently, I'm in 12th standard. Yes, you can subscribe to my channel. So, now this is a compound, as I was saying. CuSO4 is a compound. MgSO4 is a compound. But these are what? This is an acid. This is another acid. This is another acid. Okay? Understand? Please take note of that. So, the next thing we'll be talking about is mixture. Understand? These are compounds. So, can you hear me? Are you with me? Can you hear me? Before I flip it. Are you following? John, can you hear me? Bonding angles. That's very easy now. That's very easy. Though you subscribe to my channel. I'll teach you. Very easy. Or you can send me a message on WhatsApp. My link, my WhatsApp number is on somewhere around my descriptions. Bonding angles are very easy. So I'll make a video on that too. So this is this. Now let's go. Mixtures. Mixtures is when two or more elements combined physically together. Please take note. This is physical combination. They must combine physically together. Understand? When two or more elements combine physically together. So, for instance, blood, it is a mixture. You understand? Blood is a mixture. Flood is also a mixture. You understand? Because you cannot attribute a single, compound to these things. So they are, in fact, plasma is also a mixture. But I told you that sand is a compound, SiO2, because it has a chemical formula. So this is a what? This is a compound. You understand? It's not a mixture. So these are examples of mixture. And I also said petroleum. The word petroleum means crude oil. So this is also a mixture. You understand? It's also a mixture. And just like I explained, when they tell you that you are crude, the word crude is an English word which means unrefined. Unrefined. When you are unrefined, you say you are crude. Okay? That's very, very important. You understand? So let's move on from here. Another thing you want to talk about, this is chemistry for beginners anyways. Another thing you want to talk about is what we call physical and chemical change. Physical and chemical change. Now for physical change, no new substance is formed. No new substance is formed. Understand? And aside that, it can be reversible. Yes, it can be reversible. Like, for instance, if we have your water, this is water, liquid. This liquid can turn to what? It can turn to, let's say ice. Now, let me start with ice. Ice. If you eat ice, it can turn to water, abi? and if you keep eating it, it can turn to steam, abi? It can turn to steam. This is steam, abi? That means this ice going to water, going to steam, can be condensed, condensation. Then this from gas, it can turn to liquid, and it can turn to what? Solid. It can turn to liquid, and it can turn to solid, which is ice. So can you see, it can go this way and it can go this way. So it is reversible. It is reversible. Like it can go forward way, it can go this. So JAMB will ask you conversion of ice to water to steam is what type of change? It is a what? It is a physical change, because it can go both this way and it can go this way. Do we get that? Do we get that? Are you with me? Do we get that? I want someone to respond to. Do you get that, John? Please always respond, so I'll know that you're following. Okay. But for chemical change, we say new substance is formed, right? And it may or may not be reversible. Now, there's a reason why this is this, but most of the times we used to say it is not reversible. For instance, if you burn burning of wood into ash, of course, you cannot turn this ashes back to wood. So this is because this substance that is formed is a new substance from wood. This one is something you can experience at home. When you burn your wood, you will realize that burning of wood to ash, it is a chemical change. It is a chemical change. Another very fantastic example is, let's say you have sodium, you throw it inside water, right? So this is the reaction, Na plus water to give NaOH plus what? Hydrogen gas. Now you might be able to, you cannot even reverse this one back to this, but these are new substance that is different from this. So this kind of change is a what? Is a chemical change. Okay, it's a chemical change. Another very fantastic example is charring of sugar. This one is a JAMB question. 6 is H12O6. This is glucose. Now, charring of sugar. Now, charring of sugar, you would have seen this one in your secondary school, what they call Econogo 1, when that thing that looks like nails, right? That thing that looks like nails, you understand? So you realize that it is black, so they will dehydrate it, they will eat it up, they will eat that sugar up, and you realize that what you will have is C. You have only carbon. So this is the dark colored substance you are seeing that you are eating. You understand? Because you have removed water. This is water. You have removed water, H2O. But how many molecules? Because this is H12O6. You have removed 6 molecules of water, because 6 times 2, 12. 6 times 1, 6. So you have removed this. Then you are left with this. So this is what you eat in your secondary school that looks like fingernails. Have you seen that stuff before? Who has taken it? Who has taken that thing that looks like nails, like that charring? That's charring of sugar when you eat up sugar. Who has taken it before? Nobody has taken it before. I need a response. Okay, you've not taken it before. But do you know what I'm talking about? Do you know that thing that looks like sugar that they eat up, that they sell in secondary school? John. Oh my God. Okay. But this is the idea. If you dehydrate glucose to form this, so you cannot reverse this back to this. So this is a chemical. This is a chemical change. This is a chemical change. This is a chemical change. Do you get it up to this level, John? Do you get it? John, do you get it up to this level? Good. All right. So another very thing that is important for chemistry, for beginners in chemistry, is chemical formulas. How to form chemical formulas. Yes, chemical formulas or chemical equations. Now, before we go into this, you must understand periodic table. Understand? You need to understand. So if I have something like this is very, very important. So if I go like this, these are the groups. So this horizontal, these verticals, they are the groups. These are the periods. So period 1, period 2, period 3. So you must understand periodic table. Period 4. Now, so that means this is group 1. Can you see? This is group 2. This is group 3. This is group 4. This is group 5. This is group 6. This is group 7, and this is group 8. So we call this group 8 or 0. So now you want to fill in the boxes. So hydrogen is here. Then hydrogen. So yeah, do you know the first 20 element, John? Do you know the first 20 elements? Because you need to know it. The first 20 elements. The first 20 elements. I need a response. Good. So we want to fill in the first 20 elements into this table. So we start from hydrogen. There's a song that we use in secondary school then. We say hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Yes, that's the first 20 elements. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Now let's fill into it. Hydrogen is here. Helium is in group 8, so helium will be here. Hydrogen is in group 1. Helium is here. So we will now consider hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Can you see that? So that means these are the first 20 elements. So I already told you that these are the what? These are the groups. So vertical arrangement is the what? Is the groups. While horizontal arrangement is the column. Is the period. You understand? So the vertical arrangement, what are the vertical? Can you see? Understand? Why this? So this is period 1, period 2, period 3, period 4. This is group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. Another question that JAMB can ask you is that which element can fit into two groups in the periodic table? Which element can fit into 2 groups in the periodic table? The answer is what? Is hydrogen. And do you know why? Because hydrogen can either be in group 1 or group 7. It can either be in group 1 or group 7. And the reason is that and allow him to do that. Coming. Okay. Hydrogen has an atomic number of 1. So that means if I draw the shell, this is hydrogen. Just 1. So hydrogen can either lose an electron. It can either lose this electron and become H+. Because when you lose an electron in chemistry, you become positive. It's like you become like this because you have lost an electron. So this is hydrogen behaving like what? Group 1 element. Group 1 element. Hydrogen is behaving like what? Group 1 element. Because that's what they do. Like sodium now. Sodium will lose 1 electron and becomes this. Stand. Potassium will lose 1 electron and become this. You understand? So it's behaving like group 1 element. Now, hydrogen can do another thing. Hydrogen can also gain 1 electron. And this is the first electron. It can gain this and be like H-. When you gain an electron, you become minus. So if you gain an electron, you become minus. You have hydrogen here now is behaving like what? Group 7. Group 7 element. Because that's what they do. Group 7, you see something like Cl-, F-, Br-. But hydrogen cannot fit into group 7 because group 7, hydrogen is a gas. It's only chlorine and fluorine that is a gas. Bromine is liquid. Iodine is what? Is solid. So hydrogen cannot behave like these guys because they also have colored ions. They have colored. You understand? Fluorine is yellow. This one is also reddish yellow. You understand? They have colored, and hydrogen does not have that color. So hydrogen cannot fit in group 7, but it can behave like group 7, because if I tell you now fluorine, the atomic number of fluorine is what? Is 1, 2, 3, 4, 5, 6, 7, 8, 9. So fluorine atomic number is 9. That means it's 2, 7. So if you draw it 2, then the 7 will come here. 1, 2, 3, then the last one 7. If you count it 1, 2, 3, 4, 5, 6, 7. So for this guy to become complete, like 2, 8, this is what happens when what element want to do. What elements want to do is that they want to form what we call an octet shell. They want to form what we call an octet shell. They want to be stable. And to be stable is either you form a duplet or you form an octet. So that's how to be stable. So for this guy to be stable, he needs to accept 1 electron. And so that it can become 2, 8. So can you see that it just need 1 electron to be complete? So hydrogen here also need 1 electron to be complete and become duplet. You understand? So John, do you get it up to this level? Do you get it? I need a response. I'm waiting. Good. So let's continue. Now, you have to know what they call these elements. So group 1 elements, we call them a name. There's a name we call group 1. This group 1 elements here, we call them a name. Group 2 elements, we call them a name. Group 3 elements, we call them a name. Group 4, we call them a name. Group 5, we call them a name. Group 6, we call them a name. Group 7, we call them a name. Group 8, we call them a name. So we are now right, because we'll be making reference to this table. So you should draw that table. Have you drawn it? Have you drawn this table in your notes? Have you drawn this table in your notes? John, have you drawn the table in your notes? So you did not draw it. Yeah, draw it now. If you are done, let me know. Just type done when you are done. If you are done, you are drawing it in your notes. Good. Let's continue. Now, group 1 elements, so that you can be checking it. Group 1 elements, we call them alkali metals. That's what we call them. Group 2 elements, we call them alkali earth metals. This name JAMB can ask you. So these are group 1 element. Come in. So group 1 alkali metal, group 2 alkali earth metal, group 3 we call them, because boron is starting this member, we call group 3, we call them boron family. Group 4, because carbon is starting this family, we call it what? Carbon family. Group 5, because nitrogen is starting this family, we call it nitrogen family. So if we don't call it nitrogen family, this one can be called pycnogen. Pycnogen. It's also mean nitrogen family, but we can call, if we don't call it nitrogen family, we can call it pycnogen. Group 6, this one have special names. Now this group 6, oxygen, sulfur, and the likes, because they love forming oils. Also, if I ask you, is all a mixture or a compound? All is a mixture because it has impurities. There's no chemical formula that you can. Yes, there are some oils that have their chemical formula, but because it's not totally pure, you understand? So it's a mixture. So because group 6, this group 6 element like oxygen, sulfur, they love forming oils. Understand? Oils are mixtures that has different compounds. In fact, alloys, they are also mixture. Alloys are mixture. Just take note of that. So now because this group 6, they form oils, so we call them chalcogens. Now these chalcogens, what it means, anywhere you see gene, this G-E-N, it means formation. So because this chalcogen means all formers, they form oils. So that's what we call group 6 element. Now the next one is what? Group 7. Now this group 7, can see these are the halogens: fluorine, chlorine, bromine, iodine. So group 7, because they form salts, so we call them halogens. And the word halogen means what? Salt formers. Those that form salt. Halo, G means formation, so salt formers. Understand? Now the last group is what? Is group 8. Now this group 8, before we used to call them inert gases. You understand? Or rare gases. But we realized that some of them, like xenon, another example of this guy is xenon. Xenon is found to react with what? Fluorine, to form maybe xenon fluoride. So because of this formation, and they are found, some of the elements in group 8, they are now found to be reactive. Sorry, let me show you. This is xenon. When xenon combined with fluorine, it can form xenon fluoride. So because some of them are now, this xenon is group 8, some of them are now found to be reactive. We don't call them inert, because the word inert gas, when you say something is inert, it means it is non-reactive. Abi? It means it is non-reactive. So because we now see that some of them are now reactive, you understand? Some of these inert gases, they are now reactive. So we don't call them inert gases again. We don't call them rare gases again. We now call them, what do you think we'll call them? Noble gases. Now don't forget that the word noble is an English word, which means everybody wants to be like you. If they say you're a noble man, it means everybody wants to be like you. So noble gases in this case means that every element wants to be like group 8, because group 8 elements, they are the what? They've attained either duplet structure or octet structure. They've either duplet or octet. So that is the goal of chemical bonding, because all elements want to be like them. They want to be like them. Look at it. For instance, now look at helium. Helium is 2. You see that 1, 2. So helium is complete. This is what they call duplet. Duplet means 2. Now let's say neon. Neon is what? If you check here, this is 1, this is 2, atomic number now. This is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10, this is 11, this is 12, this is 13, this is 14, this is 15, this is 16, 17, 18, 19, 20. The atomic number, okay? So you can see neon here is what? Is 10. 10, atomic number 10. That means if neon is 10, that means that's 2 electronic configuration 2 comma what? 8. Can you see? It is also what? A duplet. Sorry. It is an octet. Complete. So the idea of chemical bonding is that all elements want to attain stability. They want to be like group 8 elements. All elements want to attain what? Stability. They want to be like group 8 elements. Do you all get it up to this level? Do you get it? John? I need a response. Do you get it up to this level? Yes or no? Good. 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 So that's that. Now, if you know this, because it's important though. Now let's now talk about, because this is for beginners. So let's talk about electronic configuration. Now I'm not going to go deep into this. I just wanted to know something. Now if I have hydrogen, atomic number is 1. So if I want to draw it, I will say 1. Abi? Now helium, atomic number is 2. So I will say what? Because helium is 2, that means if I want to draw this, I will say this is the nucleus. So I'll just draw 1, 2. Lithium is what? Is 3. So if I want to write it, I'll say 2, 1, 3. 2 plus 1 is 3. So I'll just do like this. That means, now look at it. I will show you something. If we have 1, 2, that means lithium. Look at, please, I want to show you something here, John. Group, then period. So if I give you this, it means, because how many shell will this guy have? It's going to be 2. There will be a center. This first one, 2 electrons, and this outer one, 1 electron. So because this guy has 2 shells, 1, 2, it is in period 2. Because the outer one here is 1, it is in group what? Group 1. This is very, very important. So if I give you something like this, let's say boron, for instance. What's the atomic number of boron? Yeah, what's the atomic number of boron? Someone should write it down. John, what's the atomic number of boron? Atomic number of boron. John. Right. Type the atomic number of boron. Atomic number of boron. I'm waiting. Atomic number of boron. Five. Good. So if the atomic number of boron is 5, that means, what will I write? I will say, since the atomic number is 5, I will say 2, because this one can only occupy 2, the first one, then the next one will be what? Will be 3. Now that means 2,3. From here, let's get the, oh yeah, tell me the group and period from what I taught you above. How many shell does he have? This is one shell, this is another shell. Because if I want to draw it now, I will say this is the center, this is 2, 1, 2, and this is 3, 1, 2, 3. So because it has how many shell? 2 shell, 1, 2. So it's in what? It's in period 2 because it has 2 shell. Because it has 2 shell, is in period 2. Now because the outermost here is 3, it is in what? Group 3. Period is 2, group is 3. Good, fantastic. Can you see? Good. Yeah, let's do this. Let's do another one. Let's say I give you sodium. Oh yeah, tell me what's the atomic number of sodium? Write down the atomic number of sodium. So it is in what? Period what? Which period will sodium belong to? Which period? What's the period and group? Good. That is 281. Oh yeah, from here, oh yeah, tell me what period is it? You are right. Yes, 11, and that is 281. So what period will sodium be? Period 8, group 1. I did not teach you that one. No. Yeah. How do you get 8? How do you get, did I even mention period 8 from here? The period that we even talk about is period 1, period 2, period 3, period 4. Then group 1 to 8. Oh yeah, tell me how that is so. Oh yeah. So 281. Count it. 1, 2, 3. Because it is 3, that's period 3. No, it's not 2. It's not 2. Yeah, look at it. 1, 2, 3. Because the period I'm counting 1, 2, 3. That's period 3. Because the group, the last one here is 1. Group 1. That's the way to do it. Yeah, let's do magnesium. What's the atomic number of magnesium? What's the atomic number of magnesium? I've already solved it. What's the atomic number of magnesium? Tell me the atomic number. Atomic number. Tell me the period. And tell me the group. Good. And oh yeah, atomic number is 12. Oh yeah, from there, oh yeah, tell me the period and group. Tell me the period and group. From there, tell me the period and group. Tell me the period and group. I'm waiting. Good. Yeah, 282. What is the period? Period. Fantastic. Fantastic. Oh yeah, let's do this one. Potassium. What is the atomic number? What is the period? What is the group of potassium? Yeah, let's do it. Yes, you are correct. That's good. Period 3, group 2. Group what? 2, yeah. Yeah, the next one, potassium. Potassium is 19. Oh yeah, what is the group and period of potassium? I agree that potassium is 19. So what is the group and period? Good. Period 4, group 1. Yes. Because potassium is 19, it will be what? 2, 8, 8. Because 2 plus 8 is 10. Plus 8 is what? Is 18. Then it remains 1. Now I said if you want to get the period, this is period 1, 2, 3, 4. Because there are 4. So this means potassium is in period 4. Because the last thing here is 1. Group 1. Let's do one more. Calcium. Let's do calcium. What's the atomic number? What's period? What's group? Yeah, John. How is calcium 21? Is calcium not part of the first 20 elements? How is calcium 20? This is calcium. How is it 21? Oh yeah. Now. Okay, good. Oh yeah, solve the question. What's the period? What's the group? Period 4, group 2. Okay. Because it is 20, Abi. So for 20, it will be what? 2, 8, 8, 2. So to get the period, 1, 2, 3, 4. So period 4. To get the group, the last one. period group 2. So that's fantastic. Okay, I think good. 2 yeah, fantastic. Now you need these things because where we are going to now, you need to know it. If not, you will not get it. Now let's go. Let's say okay, let's do another one. Let's do chlorine. Yeah, let's do chlorine. Atomic number, period, and group. Yeah, let's do chlorine. Yeah, I'm waiting. Good. Oh yeah. Write it. What is the period? What is the group? John, I'm waiting. Group 7, period 3. Can you see that stuff works? Eh? No. 35.5 is the relative atomic mass. It's not atomic number. There's one between atomic number and atomic mass or atomic weight. So 35.5 is atomic weight or atomic mass. Understand? Please take note of that. Don't miss that. Don't mix it up with what we talk about when we say atomic number. So good. So yeah, now let's go. If you know this, you are very good. So your chemistry will not be weak again. You understand? Because it's very important that you know all these basic things. You understand? Okay. Now, since we already got that the atomic number is 17, so if I want to write, I will say this is a 2, 8, 7. So that means period is 1, 2, 3. Period 3. Group is the last one, which is 7. Group 7. So now let's go. Okay, that means if I want to write formation now, we want to form compounds. Formation of compounds. Formation of compounds. So let's say we have sodium and chlorine. Now sodium is Na+, chlorine is Cl-. Do you know why we got Cl-? Do you know how we got Na+? I already explained it, but let me explain it again. Sodium is 11, and that's 2, 8, 1. Right? So for sodium to be complete, to make sense, it must lose 1 electron. So that's why if you lose 1 electron, sodium Na+ becomes 2, 8 because it has lost this electron. So this is stable. Sodium wants to attain stability. Chlorine, we already said it here. Chlorine is 17 and chlorine is 2, 8, 7. Now for chlorine to be complete, it needs to gain 1 electron so that Cl- becomes 18. So we now have, no, this one becomes what? 10. So we now have 2, 8, 8. So that is why we have this. So you can see that this is also stable. This is also what? This is also stable. So they want to attain stability. Understand? That's the idea of all these chemical combinations. Okay. Now, so let's go back to this. If you understand these two things, do you get these two things that I just explained? Do you get it? John? Good. So let's continue. Now, if I want to write the compound Na combining with Cl. Now, because I know that this one to be stable, it will be Na plus. This one to be stable, it will be Cl minus. Now, this thing that you are seeing here is oxidation state. It's what? Oxidation state. Now, this stuff we are seeing here is +1. This one is -1. Now, this is not what we combine. What we actually combine is 1 without and 1 without a charge. So this one we call it oxidation state because it has charge. So oxidation state is the combining power of an element with a charge, either positive or negative. But this one that does not have any charge, we call it valency. We call it what? Valency. So valency is the combining power of an element without a charge. So this is what we combine. So you now see in your textbook they will cross this one, that this one should come here, then this one here should come here. So you now have something like Na, the one that is here, then Cl, the one that is here. But you don't need to write it since it's just one. NaCl. That's the way they've combined. Do you get that? Do you get that? I need the response. John, do you get it? Good. Now, let's move further. So we'll go to another one that is advanced and move like that. Now let's say we have H plus combined with SO4 2 minus. H plus combined with SO4 2 minus. Now what will I first write? I'll first write what? +1. That is for this one. Then I'll write -2. Another thing you have to know is what they call radicals. You have to know what radicals are. Radicals are what? They are a group of atoms which possess a charge. You understand? So NO3 minus is a radical. SO4 2 minus is a radical. Understand? Cr2O7 2 minus is a radical, because this is sulfur, this is oxygen, this is nitrogen, this is oxygen, this is chromium, this is oxygen. These are groups of atoms that possess a charge. In fact, NH4 plus is also a radical. So that's what we call radical. Can you see? These are radicals. Now let's go. That means the charge here is +1, the charge here is -2. This thing you are seeing here, they are called what? Oxidation state or oxidation number. But that's not what we combine, because it's just the one that has charge. So what we combine is 1, and what we combine here is what? 2. So they will now cross. This one will go here, this one will go here. So this one, the 2 becomes here, this one becomes here. That's why if I want to write H now, if I want to bring this H down, I must write the 2 that it carries. Then SO4, I must write the 1 that was given to it from hydrogen. I will not write 1, but you don't need to write it since it's just 1. That's why it will form H2SO4. Do you get it now up to this level? Do you get it? Good. Now let's say, oh yeah, John, let's do this one. H plus NO3 minus. Write the compound that will be formed. What's the compound? Good. 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 Which I know to how? Well, this is plus 1. This is minus 1. But what we combine is 1 and 1. So this one will cross to this side. This one will cross to this. So you now bring this one here. H. You bring this one here. Alright, let's do for K plus and Cr2O7 2 minus. Alright, let's do for this one. I'm waiting on what is the compound. Good. But the R is not capital letter. It's small letter. Take note of that. So let's go. That's good because this is plus 1 and this is minus 2. What we combine is 1. What we combine is 2. So this one will come and meet here. This 2 will come and so you have K2 Cr2O7 and the one that will come here will just be there. So you don't need to write it. So that's the way to write that. So now let's do another one. Let's say we have K plus and MnO4 minus. Oh yeah, how do you write the compound? What will it be? KMNO4. Good. That's good. Fantastic. Okay. Now, the next one we talk about, since we know how to form compound now, is how to balance equations. Balancing chemical equations. Balancing chemical equations. Okay. Now the first thing you want to note is that this one is a JAMB question. JAMB question is that balancing of equation follows the law of conservation of mass. And what does it state? It's just trying to say that you can mass or matter can neither be created nor destroyed. What do I say the balancing of equation? What law does it follow? Balancing chemical equation, what law does it follow? Yeah, write it in the comment section. Balancing chemical equation, what law does it follow? Is a JAMB. This one is a JAMB question. What law does it follow? Write it. Because you must know this one is a JAMB question. What law does it follow? Conservation of mass. John, what law does it follow? What law does it follow? What law does it follow? It's a JAMB question. Law of conservation of mass. Good. And you already know that it states that what? Matter can neither be destroyed nor created. That is, what it means is that, look at what it means. Look at what it means. I will show you something now. If I have, look at it. Let me give you for example, look at what happened. People cram it, but you don't need to cram it. Look at what happened. If you have CaCO3 to give CaO and CO. Now this is, do you think this is this correct? Just tell me if this is correct. Yes or no? Is it correct? Is it correct? Is this equation correct? Just say yes or no. Is this equation correct? This equation, is it correct? Good. It is not correct. It is not correct. Good. Yes, it is not correct. Why? If you look at this is Ca, this is C, this is O3. Now look at it, CaCa, yes, C, yes, but the oxygen here is 2 and the oxygen here is 3. That means we've done something we call destruction. We have destroyed matter. And the law is stating that matter is neither created nor destroyed. So, and if you do this, it means you have destroyed matter. You have already breached the law of conservation of energy. So that's why that law is important. So in this case now, this is not correct. It does not follow the principle. You understand? So the actual thing is that this should be what? This should be 2. Such that Ca, how many Ca do we have on the left hand side? Left hand side and right hand side. That's the way you'll be doing it. How many Ca? We have 1. How many Ca? We have 1. How many carbon? We have what? 1. How many carbon is here? Carbon 1. How many oxygen? 3. How many oxygen? That's 3. So this is a balanced equation. The first one is not balanced. So that's the way we explain that. Now let's be moving like that. Now let's say we have KClO3 to give KCl plus O2. This is the compound that is going to give. KClO3 to give KCl and O2. Now let's start. The first thing the way to balance there is a trick to it. But the first thing you want to do is that you want to check, and there's a principle. You don't alter, please write it, note that you don't alter the compound by, let's say, putting 2 here or putting 4 here or changing this 2 to 6. You don't do that. You don't alter at the subscript level. These are the subscript. You don't alter here. You only alter at this level. You alter at this level, at the moles. This is what you alter. Alter. You can alter that. You can alter that. You can alter that. Like these are the moles or coefficients. Moles or coefficients. You can call them coefficients. These are the things you can alter. Coefficients. But you don't alter at this level, at this ones and this ones. So now let's go. If you have KClO3 to give KCl plus oxygen. Now look at it. How many potassium? What the elements we have are, these are potassium. And we have potassium here. We have Cl. We have Cl. Then we have oxygen. We have oxygen. The principle states that you don't destroy and you don't create. So it means the number of potassium that must be here, the number of chlorine that must be here, the number of oxygen that must be here must be equal to the number of these three guys that must be here. If you don't do that, you have altered the law. Okay. Now, potassium here is 1. Potassium here is 1. Balanced. Cl here is 1. Cl here is 1. Balanced. Oxygen here is 3. Oxygen here is 2. There's a problem. Because the number of oxygen that must be here must also be what? 3. You understand? If this is 3, this must be 3. So because this is 3 here and this is 2, the way to do it is that the LCM here, or you just multiply. If this is 3, just multiply this one by 3. So 3 times 2 becomes what? 6. Now to balance this 6, this oxygen here must also be what? 6. So if this is 3 times 2, that is 6. Just come and multiply. You know, I can't change it. If this one is 6 now, it will be so stupid of me to change this one to 6. So what I will do is, because this one is already 6, I will come here and say, oh, to make this one 6, I have to add 2 here. Now, because I cannot alter at this level, I can only alter at this level. Because I altered oxygen at this level, it has affected other ones. Eventually, potassium has increased to 2. Chlorine has increased to 2 because I altered it here. And the chlorine here is still 1 and potassium here is still 1. So to make it balanced, I cannot put 2 here or put 2 here. I will now put another 2 here. Now if you realize the potassium here is 2, the potassium here is 2. Chlorine here is 2. Chlorine here is 2. Oxygen here, 2 times 3 is what? 6. Oxygen here is what? 6. This is a balanced equation. I did not destroy anything and I did not create anything. What is here is what is here. Do you get it? Do you get it? I need a response. Do you get it? Good. Good. Now, let's say I have something like this. Let's go a bit advanced. Let's say I have C2H6 plus oxygen to give CO2 plus water. This is a combustion reaction where an alkane, this is an alkane, reacts with an oxygen to give CO2 and water. So this is a complete combustion. Because it is partial, it will be CO not CO2. Okay, let's continue. C is here. C is here. Hydrogen is here. Hydrogen is here. Oxygen is here. Oxygen is here. Okay. Now, if we want to balance, let's start. We already said that C, hydrogen is here, oxygen is here, C is here, hydrogen is here, and oxygen is here. Now, the number of C here is how many? What's the number of C here? This is the left hand side, and this is the right hand side. So what is the number of C? The number of C here is how many? John, what's the number of C? The number of C here is 1 on the left hand side. Are you sure? How is it 1? Please look at what I'm pointing out. This side. How many C do we have here? What is the number of C here? How many C? How many carbon do we have here? How many carbon? How many carbon do we have here? Oh yeah. How did you get 1? Yes, it is 2. Is this not 2? The number of carbon here is 2. How many carbon do we have here? How many carbon do we have here? How many carbon do we have on this side? How many carbon do we have here? 1. Good. Let me write it again so that you follow. Okay. Now, if this carbon is 2, that means I can make this, and this carbon is 1. My job is to make this carbon here be what? 2. So the only way I can make this carbon to be 2 is to add 2 to this place. That's my only way to make that carbon to be 2. Leave oxygen. Leave other one. My job is to make the carbon here to be equal to the carbon here first. I've done that, right? The next one is, how many hydrogen is on this side? How many hydrogen is here? How many hydrogen is on that side?
You get class? You do class? I thought you hydrogen of this one. So the man so good.
Oh yeah, how many hydrogen? 6. Good. How many hydrogen is on this side? How many hydrogen is on this side?
I bet. No, they use that. What's it big with?
2. So my job is to make the number of hydrogen here to be equal to the number of hydrogen here. And how many hydrogen will I add? What will I add here? If I want to make the number of hydrogen here to be equal to the number of hydrogen here, what will I add to this side? Is this I'm going to add, or will I change this to? I'm going to add it here, Abby. So what will I add to this side? 3, good. John, what will I add to this side? Yeah, spark. The remaining one wait there now.
Okay, wait there.
Yeah. No, be serious.
Come on.
Sorry.
What water?
Yeah.
Drink water go on.
No, there was no water there before.
This is a new water now.
Yeah.
Hey, that's what I'm saying, man.
There was no water there.
Oh,
before.
okay.
He said I didn't feel that. So yeah, 3, good. 3. So that's how I add 3 here, Abby. My job with carbon is done. My job with hydrogen is done. So I'm left with one person. And that person is what? Oxygen. That person is oxygen. Abby, I'm left with oxygen now. Now, so carbon here is 2. Carbon here is 2. Hydrogen here is 6. Hydrogen here is what? 2 times 3. Hydrogen here is 6. So the only thing I'm left with is what? Oxygen. And oxygen here is 2. How many oxygen do we have here? 2 times 2. Oxygen is 4. Yeah, 2 times 2. Then 3 times 0. 3 times 1, sorry, not 0. 1. And that's plus 3. That means the total number of oxygen here is what? Is 7. And the total number of oxygen here is what? Is 2. Now, this is where your math knowledge has to come in. How do I make 2 oxygen that is here? How do I make it to be equivalent to this one, the number of oxygen that is here? Now look at it. It's very easy, right? If I want to make 7, you know the total number of oxygen here is 7. The total number of oxygen here is 2, right? So how do I make this one to look like this? Now I can do something. What do you think I can do? Look at it. I want to do magic. If you don't know, like, pay attention now. Pay attention, because it is C2H6 plus O2 to give 2CO2 plus 3H2O. Which 3? This is 3 here. It means 3 of oxygen now. So that's how I got 3. 3, how many oxygen is here? Is 3. 2 times 2, 4 oxygen. 3 times 1, 3 oxygen. Do you get how I got 3 like that? Do you get it? Good. Oh yeah. Now, I already said oxygen here is 7. Oxygen here is 2. Oxygen here is 2. Oxygen here is 7. Now, I can do something. Look at what I will do. If I multiply this one, look at it. C2H6 plus, if I say 7 over 2 multiplied by oxygen, which is equal to 2CO2 plus 3H2O. Now, can you say I am wrong with this? Does this make sense to you? Because look at it, you have to pay attention. 7 over 2 times oxygen 2. It means, I'm coming. It means the oxygen here is 2, right? Let me let me not to pay attention to this thing, because you have to understand it. Okay, now look at it. Because I want you to pay attention. This is oxygen here is 2. That means I have 7 over 2 oxygen times 2 oxygen. So 2 can cancel 2. And eventually the oxygen here will be what? 7 oxygen, which is equivalent to the number of oxygen that is here. Look at it. Or another thing I can do. Now pay attention here. It's very tricky, but it's not hard. Pay attention. Another thing I can do is that I can say, look at it. Let me write it on another place. C2H6 plus 2CO2 plus 3H2O. Now I can say 3.5O2 because 3.5 times this, 3.5 times 2 will give me 7 oxygen. Abi, is this right? Do you get this one? You know, this 3.5 is actually 7 over 2. I just want you to see it that way. It's actually 7 over 2. 7 over 2, 7 divided by 2 is 3.5. Do you understand that? Do you get that? Because I want to let the number of oxygen here to be equal to the number of oxygen here. That's the joy. That's the scope. Good. Now, look at it. C2H6 plus 7 over 2 O2 to give 2CO2 plus 7H plus 3H2O. But because I can find a way to make sure that this thing is still O number, or because this one 3.5 of oxygen is not showing O number, what do you think I could? I can multiply through by what? By 2. I can multiply everything by 2 so that I can make this one O number. Look at what will happen. If I multiply through by 2, please, I want you to pay attention. I can multiply everything by 2. Right? I don't know if you guys are getting this thing. Or I can also leave it like this. I can also multiply through by 2. Yeah, let's do that. Let's multiply through by 2 and see what will happen. Yeah, let's go. Should we go? Multiply through by 2. That means 2C2H6 plus 7 over 2 times 2 O2 equals to 2. Multiply this one by 2 will give me what? 4CO2. Multiply this by 2 to give me what? 6H2O. Now this means 2C2H6. 2 can cancel 2 and become 7O2 to give 4CO2 plus 6H2O. Yeah, let's start. How many C do we have here? How many C do we have here? How many hydrogen do we have here? How many oxygen do we have here? Hydrogen, oxygen. Oh yeah, let's start. Oh yeah, let's go. How many C do we have here? How many C do we have? The C here is 4. The C here is also what? How many C do we have on this side? These are good. 4C. So how many C do we have here? 4C, Abi. Good. Because this is 4C. That's all. There's no other C. How many hydrogen do we have here? How many hydrogen do we have here? How many hydrogen do we have? Hydrogen. How many hydrogen do we have here? How many hydrogen do we have here? Hydrogen. How many hydrogen? How many hydrogen do we have? Why is it 7? How do you get 7 hydrogen here? How do you get 7 hydrogen? This is hydrogen here. How is it 7? These 2 will affect 6. 2 times 6 is 12. How is it 7 hydrogen? So 2 times 6 is what? 12. Good. Hydrogen is 12. Now, how many hydrogen do we have on this side? How many hydrogen do we have on this side? I'm waiting. 12. Good. Good guy. 12. Good. How many oxygen do we have here? If you can solve this one, you can solve any balancing of equation question. Because this is the peak. This is the height of it. So how many oxygen do we have here on this side? How many oxygen are here? I'm waiting. How many oxygen are you seeing on this side? 28. Good. Oh yeah, how do you get 28? Someone said 40, someone said 28. Oh yeah, how do you get 28? I did not ask you the two. I said this side. I'm asking for one side. One side. I'm comparing. What must be here must be equal to what must be here. So how many oxygen is here? You can't say 28. It is what is here. I did not ask you for the two sides. What is on this side? 7 times 2. That's what? 7 times 2 is what? What is 7 times 2? So the number of oxygen on this side is 7 times 2. I agree. What is 7 times 2? Is it 28? Where do you see the other 2? Hey, God. 7 over 2 times 2. 2 has already cancelled 2. So I only have 702. So this is 702. So to get the number of oxygen on this side, it is 7 times 2, which is what? 14. Oh yeah, how many oxygen are on this side? How many oxygen are on this side? How many oxygen are on that side? How many oxygen do you have here? And you tell me how you got it. How you got the number of oxygen on this side. How many oxygen do you have here? How many oxygen? I'm waiting. And you tell me how you got the number. No one knows the number of oxygen on this side. 14. Good. How do you get 14? How do you get 14? How do you get 14? John. How do you get 14? How do you get 14? John, how do you get 14? I'm waiting. John, how do you get 14? John, how do you get 14? I'm waiting for you. How do you get 14? John, are you still here? Okay. This is 4. And this is oxygen. So 4 times 2 is 8. So oxygen here is 8. Plus, since oxygen here is 8, plus 6 times 1. 1 oxygen. So that's plus 6. So that is equals to 14. So the number of oxygen on this side is what? Is 14. So this equation is balanced. Do you all get it? 6 times 2. Where do you see the 6 times 2? Where do you see the 6 times 2? You should always have a reason for your answer. Okay. Oh yeah. Do you all get it? John, do you get it? Do you get it? Now, we have to do our own. Oh yeah, let's go. Balance C4 H10 plus oxygen to give CO2 plus H2O. Oh yeah, I'm going to just give 2 minutes to do this. 2 minutes. Yeah, what is the balanced equation? 2 minutes. 2 minutes. Oh yeah, go on. Yeah, balanced equation. 2 minutes. 2 minutes. Who has gotten it? Okay, because of, just tell me what is here, X, what is here, Y, what is here, A, and what is here, B. So I just want you to tell me A, I don't want you to tell me B, I want you to tell me X, and I want you to tell me Y. So that's what I need you to say. Because that's what JAMB will ask. I want you to just tell me what is X, what is Y, and what is A and B. I'm waiting to know what is X and Y and A and B. Nobody has gotten anything. I'm only seeing one response. A is 10, X is 4. B is 13. John, what's your answer? Okay. Let me solve it. I'm giving you enough time. X is 6. Okay. John said S is 6. Oh yeah, I'm with you. S is 6. What is Y? What is A and what is B? Okay, there's no time. Let's just solve it. Now C4, H10, B is 5, okay, plus O2 to give CO2 plus H2O. Okay, oh yeah, leave whatever you are doing and pay attention. Leave whatever you are doing and pay attention. I'm giving you enough time, up to like 5 minutes. None of you got it. So leave whatever you are doing, pay attention. C4H10O2 plus this. Now, how many carbon do we have here? We have 4. Leave whatever you are doing. I don't want to hear you not understand. Leave whatever you are doing. How many carbon do we have here? 4. Carbon here is 1. So I need to make this one 4 so that carbon here can be 4. Understand? How many hydrogen do you have here? 10. And hydrogen here is what? 2. So to make this hydrogen 10, I need to add 5. So that 5 times 2 will be 10. We are done with carbon and hydrogen. You understand? So now it remains oxygen. Oxygen here is 2. But oxygen here is what? Is 9. And oxygen here is 9. Oxygen here is 2. So how do I make 2 to be equal to 9? Is to multiply both sides by 9 over 2. Look at what I will do. Sorry, no, that's what I meant. CH10 plus is to make this one looks like 9 over 2 times O2. So to give 4 CO2 plus 5 H2O. Now doing this, you know what happens? This one means like 9 over 2 times 2. Don't think that this 2 is below, is on top, is like 2O. What this thing means, O2 here means 9 over 2 times 2 oxygen. So 2 can go with 2. Then I have 9 oxygen. So the oxygen here now, which is C4H10 plus 9 over 2O to give 4 CO2 plus 5 H2O. The oxygen here now is equal to the number of oxygen here. But I cannot leave it like this. Your exam can say this, you understand? But I cannot leave it like I have to multiply all through by what? By the denominator, which is what? Which is 2. So when I multiply all through by 2, I have 2 C4H10. Then because I multiply by 2, that 2 will cancel this one. Then I have 9 O2 to give 2 times 4 is what? 8 CO2. 2 times 10 is 2 times 5 is 10 H2O. Yeah, let's go. Yeah, now. Yeah, let's start. How many carbon is here? Oh yeah, how many carbon is here on this side? How many carbon is on this side? How do you get 6? I'm waiting. How do you get 6 carbons? How do you get 6 carbons? So 2 times 4 is 6. Is 2 times 4 6? Carbon here is 8. How many carbon is on this side? How many carbon is on this other side? How many carbon is here? How many carbon is on this side? On this other side here. How many carbon do we have here? How many carbon is here? 8. Good. That means we are done with carbon. Now, hydrogen. How many hydrogen are on this side? How many hydrogen do we have here? How many hydrogen do we have here? How many hydrogen do we have on this side? How many hydrogen are here? How do you get 10? How do you get 10? How do you get 10 now? Don't say something you don't know. Why you? Are you distracted? How do you see 2 times 10 to be 10? How many hydrogen do you have on this side? God, don't forget, oh, this is 10. Oh. 10 H2O. So how many hydrogen do you have on this side? How many hydrogen do you have on this side? 20, Abby. So that means hydrogen is 20, 20. So the last one is oxygen. So how many oxygen do you have on this side? How many oxygen are here? How many oxygen? How many oxygen? How many oxygen do you have here? Oxygen. How many oxygen do you have here? How many oxygen do we have here? Oxygen do you have here? How many oxygen do you have here? How do you get 20? How do you get 20? I'm waiting. How do you get 20? Don't forget, this is the only oxygen that we have here. Oh. So 9 times 2 is it 20? Is 9 times 2 20? So how do you get 20 before? So oxygen here is 18. How many oxygen do we have here? $18. Good. So coming. Okay. I'm coming. So what the way you know this is that whatever will be here must be what will be here, right? So that's the way to be able to balance these equations. Do you understand? I'm coming. Think. Ooh. I'm coming. So C for H10 O2 to give CO2 plus H2O, right? So we can have C for H10 plus O2 to give 4 CO2 plus 5 H2O. trying to say that I was saying something something happened already. The oxygen, we didn't get it very well because I was saying that something is happening. Look at it, because I have to, because I was teaching, so I didn't follow along very well. So 4CO2 plus 5H2O. Oxygen here this is 4 times 2, 8, abi, plus how many oxygen? 5. So the total number of oxygen on this side is 13. Is 13. You understand? It's 13. I shall know. So I want to make the oxygen on this side is 2O, and the oxygen on this side is 13. So I want to make it to look like the same thing. So what I will do is C4H10 plus 13 over 2O2 to give 4CO2 plus 5H2O. Right? So what I will do is multiply through by 2. That's 2C4H10 plus 13O2 to give 8CO2 plus 10H2O. Because I was saying that there is a mistake somewhere. So can you see 13O2, 8CO2 plus 10H2O. So that means C here is, carbon here is 8, carbon here is 8, hydrogen here is 10, 20, 2 times 10, 20. Hydrogen here is what? 2 times 10, that's 20. Then the last one is oxygen. Oxygen is 30 times 2, 26. Then oxygen is 8 times 2, 16. 16 plus 10 times 1, that's 26. That's balanced. Exactly. So this is the balanced equation, please, because I was carried away the other time. So we've used more than 2 hours, no more than that. So this, we've been able to talk about a lot of things. We started from atoms. We define molecules. In fact, we started from chemistry. Started from chemistry. What is chemistry? You understand? We start atoms, molecules, elements. Started from, we talk about elements. We talk about compound. We talk about mixture. Right? We talk about radicals. We talk about, talk about balancing. No, that's the last thing we talk about. We talk about periodic table, how to write chemical compound, or yes, chemical compound, how to write chemical compound. Then we talk about balancing of equation. So I mean, if you are a beginner in chemistry, you should know what this is, right? So now, assignment. How do you balance 6,7 H16 plus oxygen to give CO2 plus H2O? That's number 1. Number 2, how do you balance H2O plus HNO2 to give HNO3 plus HNO2? Balance it. Number 3, if I'm done, you take a screenshot. How do you balance C8 H16 plus oxygen to give CO2 plus H2O? Number 4, C20 plus H42 plus oxygen to give CO2 plus H2O. So these are the assignments. Take a screenshot now. Have you done that? Take a screenshot. You have done that, type yes. God, you are done now. Type yes, you have done that. Take a screenshot. Type yes, we have done that. John, have you done that? So this is where we'll stop. Good. So that's the assignment, John. So I hope you gain something. You're done. So yeah, that's chemistry for beginners. So this is more than 2-3 hours already. Yeah. So we did a lot. Did a lot. So did a lot. See my notes. Kai. See my notes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, almost 20 pages. So yeah, you're welcome. Well, if you are just joining, if you have not followed us, subscribe to my channel, turn on your notification. Yeah. So see you next time. So John, so solve the assignment. You can drop the answer to the comment section of this video. All right. So yeah, thank you, sir. You're welcome, John. Yeah, JAMB must obey. All right. So see you in the next video. Out in my other videos. Bye for now. Subscribe to my channel if you have not. Yeah, the chemistry tutor. Bye for now. Okay. Let's see. Let me see. Okay.